So the absolute value function is going to be very important to us in calculus. And again, I could write it generically using my A and my H and my K. So it looks very similar to all the others that we've looked at so far. And HK, of course, determines the vertex. But something a little more important about this is that absolute value graphs are actually what's known as a piece function. And so every time you see one, you want to start to get yourself in the habit of writing it in two separate pieces. And if you remember from the description up above, so let's say I have the equation y equals absolute value of x minus 2. Of course, I know the vertex is at 2, 0 because h is 2 and k is 0. But what you really want to do is you want to say, okay, if this thing is positive, now that whole thing would be greater than 0 if x is greater than or equal to 2. And the stuff inside would be negative if the stuff inside, or rather if x was less than 2. Because if I plug in a 2, excuse me, or if I plug in something that's less than 2, of course this is going to give me a negative quantity, and when I get a negative quantity, I want to take the opposite of that. So 2 is the dividing point, and interestingly enough, isn't it, that that's h, and so the stuff inside I won't have to worry about changing the sign on when x is greater than or equal to 2, but I will have to change the sign on it if x is less than 2. Very important about absolute values. And this next function we'll see a fair amount. It's called a step function, and lots of things in real life work as step functions. For example, your phone bill. So they charge you, let's say 47 cents a minute when you're out of the country, and you talk for 30 seconds, you still get charged 47 cents. If you talk for 32 seconds, you still get charged 47 cents. If you talk for 58 seconds, you still get charged 47 cents. If you talk for a minute, you get charged 47 cents. But if you talk for a minute and a second, now you pay 47 cents times 2. So that's why you see this going up in what looks like steps. And notice, in order to make sure that it is actually a function, we have one end closed and the other end open so that this does in fact pass vertical line test, because I'm only going through this point because this point does not exist. Okay, so again, it follows just like all of the others in that I can use h and k, so I can have, an x minus h and then a plus k. What you need to know is that essentially it does what we call truncating. So if I have, let's say, its greatest integer function, and your calculator does this one also. But if I have a 2 in there, of course it goes to 2. If I have a 2.1, it goes to this one. So 2.1 would actually go to 3, although on this one, I think this is supposed to have double bars, or yeah, around it. Okay, sorry, I was being a nitwit for a second. This is greatest integer function, and it does truncate because you're trying to get the greatest integer contained in the number. So if I have, in fact, it doesn't need the double bars, just kidding. If I have 2.1, the greatest integer that you can get out of that is 2. And if I have 2.99, it still goes to 2. But if I get 3.01, it now goes to 3. Okay, see you on the next video.